All right, so like I said, we'll be going over lesson 4.01 today, looking at fractional exponents. So last class, we looked at exponent rules. We talked about product rule, quotient rule, power rule, zero exponent rule, and negative exponent rule. In today's class, we'll be looking at just one singular thing, which is fractional exponents. We're going to be taking a different approach, at least to how I learned it. This is going to be a little bit more conceptual. It's not so much procedural. And what I mean by that is the way I learned it, there was like a trick, like this number does this and this number does that. This time around, like I said, we're going to do some conceptual work here. So we'll be doing a lot of work with fractions, which might seem like it's something really simple, but I promise you it can get quite complicated. So for now, let's just go ahead and begin with the warm-up. I would like for you guys to try out, there's a lot of questions here. So questions 1 through 8 are utilizing the exponent rules. Questions 9, 10, and 11 deal with fractions. So with your team, let's shoot for about 8 to 10 minutes to go ahead and complete this warm-up. You guys can go ahead and get started. Please read all instructions. Okay, so by now we should be at least 50% done with the warm-up, if not more. So let's go ahead and start going over this, and hopefully I can address some of your concerns or questions here. Starting with the first one, we have 5 to the third. 5 times 5 times 5. What is 5 times 5 times 5? That's equal to 125. Let's go ahead and write that down. Equal to 125. Okay, so far we haven't used any rules yet, okay? Number 2, 4 times 3 squared. Here you have to do PEMDAS. So we have to do the exponents first and then multiply. So we're doing 3 squared. What's 3 squared? 9. So I have 4 times 9. What's 4 times 9? 36. So our solution is 36. Okay, like I said, we haven't done any rules yet. We haven't used any of the rules from last class. Number 3, negative 3 to the 4th power. This is negative 3 times itself 4 times. Now, every pair of 3's make a 9. So this is really 9 times 9, which is equal to 81. Okay. All right, this one, a little tricky. Keep in mind that the exponent is going to tell you how many times your base needs to get multiplied by itself. In this case, the base is a fraction, so you need to rewrite the entire fraction out. So the fraction 3/5 will get multiplied with 3/5. You multiply the top and then the bottom. 3 times 3 is what? 9, and 5 times 5 gives you 25. All right, so far, we're just evaluating the exponents. We haven't really used any of the rules. Let's go ahead and do that in the following set of questions. 2 to the third times 2 to the third. What rule can I use here? If I'm multiplying the same base, what rule can I use? The product rule. Excellent. The product rule. So we get 2 to the 3 plus 3 power, right? Because the product rule, what it tells you is you can add the exponents, giving us a solution of 2 to the 6th power. Okay? All right. Next question. 7 to the 4th divided by 7 to the 6th. What rule can I use here? If I'm dividing the exponents, what rule can I use? Dylan? The quotient rule. Very good. What the quotient rule tells you is you can subtract the exponents. 7 to the 4 minus 6. But when I get to this part, I get 7 to the negative 2. I have to use a separate rule now. It's a different one. Now I use the negative exponent rule. And what that tells me is that I need to convert this. I need to take the reciprocal of 7 to the negative 2nd power, which is going to become a fraction. 1 over 7 squared, or 1 over 49. Okay? Let me go ahead and move this a little bit out of the way. Oops. All right. Let me move this. Very good. Okay. 5 to the negative 2nd. Here's another example of the zero, not the zero, the negative exponent rule in play. We would need to convert this or take its reciprocal. So 5 to the negative second would become a fraction 1 over 5 squared, which is equal to 1 over 25. Anytime you have a number with a negative exponent, if it's in the top, you bring it to the bottom. If it's in the bottom, you bring it to the top. That process of taking its reciprocal will make the exponent positive. Okay, then we have 16 times 2 to the negative third power times 5 to the 0. Let's start with 16. We can't do anything with 16, so I'll just rewrite that. 2 to the negative third. Like I said, I have a negative exponent here, so I need to make this into a reciprocal or a fraction, 1 over 2 to the third. And then what is 5 to the 0? What is anything to the 0 power? 1. Okay, so we still got to clean this up a bit. 16 stays as 16. 1 over 2 to the third. Let's simplify 2 to the third. What's 2 to the third? 8. So this is 1 over 8. Which is, I could rewrite this as 16 over 8. Which is a simple division problem. What's 16 divided by 8? How many times does 8 go into 16? Twice. It goes in twice. So we get a final solution of 2. All right? So questions, excuse me. Questions like number 8 is the kind of stuff you guys will see on, say, like a quiz or an exam. Because at this point, we can do like 2 or 3 step simplifying expression problems or simplifying exponent problems. So it's going to be a problem where you have to use at least 2 or 3 rules together. Okay, now let's look at number 9. Number 9 tells you essentially that 4 friends went trick-or-treating. They want to split evenly 120 pieces of candy. So how should they split that? How should they split 120 pieces of candy? Among how many people? 4. So we have 120 that is being split into 4. If 120 pieces are split evenly into 4, how many does each person get? 30. So each person gets 30. If you wanted to do a visual, you could do this. You could draw like a circle, right? Split into 4. Each person gets 30 pieces of candy. So the visual helps you see the exact fraction. If each person is getting 30 pieces of candy, what fraction of a whole do 30 pieces represent? 1/4 or a quarter, which answers the second part. So each person is getting 1/4 or 30 pieces. Okay. All right. Let's look at the next one. You have $200 in your wallet. You spend 1/5 of your money on a present for your crush. It's a lot of money to spend. I wouldn't recommend spending that much. How much money do you have left over? What fraction of the original 200 do you still have left over? So let's say that this circle represents 1/5 or represents all your money, right? So this would be split into fifths. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. Let's pretend that's even. What is 200 split evenly into 5? What do we get? 200 divided by 5. What do we get? Think about that division problem. 5 goes into 200 40 times. So that means each of these, each fifth, is composed of, in this case, the units are dollars. So each fifth is $40. Now, if you spent $40, how much are you left with? So you're left with 160, which is the equivalent of 1, 2, 3, 4 4/5. Okay? If you're writing this down, please write down the visual so that you can refer to this later. All right. And then we have the next question, 11. Mr. Ratburn tells Buster that 1/2 of a pizza is the same as 2/4. Buster doesn't understand why. Draw a picture that might help convince Buster that a half is the same as a fourth. So let's start with the pizza. Pizza is obviously a circle. How could I show that 1/2 is the same as 2/4? What would I need to do here? So right now it's currently split into half. That means 2 slices, 2 really big slices. Make another circle, put it into 4. Okay. So I could make another circle and split this one into fourths. And maybe if I shade it in, I might be able to show that 2 out of 4 slices is the same amount as 1 out of 2 slices, which I can see here, right? So this one is split into halves. This is 1/2 and 1/2. This is 1/4, 1/4, 1/4, and 1/4. As you can see, the total amount of pizza is the same, which goes to show you that 1/2 is the same as 2/4. I could split this again into eighths, and then how many eighths would be equivalent to 1/2? 4 eighths. I could do it again. Maybe if I was doing a pizza party and like I bought 1 pizza for the whole class, I would split into 32 slices, for example, which would be tragic because everyone would get like 1-inch pizza. But 16 slices out of 32, you guys can kind of see the idea here. Okay. All right. So before I move on to the next section, are there any questions here that I can go ahead and clarify for you guys? All right. Then let's move on. The next section is an accountability quiz. So I would like for you guys with your team to try out questions 1, 2, and 3. We'll stop there for now. Read the instructions. It looks like you guys are just drawing and labeling. All right, so use the figure below, which represents 1 sheet of brownies. Use that to guide you as you answer the following questions. I'll be walking around to help you out. All right, let's take a look. So this was a little challenging at the beginning because some of you guys didn't know what to do. That's okay. Let me give this a chance to connect. There it is. Now, one of the first things you guys had to identify was, well, if this right here represents 1 sheet of brownies, how many individual little boxes make up a whole brownie? So I saw some of you guys do this. You counted up that there were 12 boxes down below and 4 boxes on the side. So you just did like an area model or area measurement, and you figured out that there's 48 squares. So 48 squares make a whole. So if 48 squares make a whole, how many squares make 1/4 of a whole? In other words, what's 48 divided by 4? I know you guys got this because I looked around and saw your answer. So what do we get? 12 boxes, 12 little boxes. Now, if you wanted to split this evenly, then 1/4 of 12 is 3. So I would go 1, 2, 3. That's how long I would make my rectangle by 4. So this right here would represent 1/4, or 12 little rectangles, 12 little boxes. All right. Obviously, if I wanted to show the rest, this would be another 4th. This would be another 4th. And finally, this would be the last 4th. Notice how I'm only shading the one that I really want to show, which is one of those 4ths. The rest are just there to kind of symbolize or to show you what the entire piece looks like. Okay? All right. So that was kind of easy. The next one, splitting it into 6 now, 6s. In other words, what's 48 divided by 6? 48 divided by 6. Because when we do 48, like we split 48 squares into 6 pieces or 6 parts evenly, that'll give you the number of squares you need to represent 1/6. So 48 divided by 6 is not 7. 8 is correct. 8, yes. So that means you need to show 8 total parts. So that instead of going up to 3, like 3 sideways, it's a 2 by 4, which shows 1/6. So this is 1/6. I color it in because I want to show one of those. And I'm just going to repeat this process until I show 5 of these. 1, 2, 3, 4, 5. This one's bad. 5 and 6. So that's 1/6, 1/6, 1/6, 1/6, 1/6. A total of 6 sixes, but I'm only going to shade 5 of them. Okay. So if 8 little squares represent 1/6, if I wanted to show 5 sixes, I would need to shade in 40 of them, which is what we see here. When we don't see, or when we see that 40 of them are shaded in, 8 of them are not. Okay, so that right there represents 5/6 of a sheet of brownie. Now, by far the trickiest one was the next one. So let's see how you guys tackled this one. Draw and label 4/3 of a sheet of brownies. So this is an improper fraction. 4/3 is bigger than a whole. So theoretically, when you shade in, you should have more squares than the initial 48 because you have a third extra basically. Now, to determine once again how many little squares you need, you would need to split up 48 into thirds, giving you an even amount of 16 little squares. So how would you represent that? Right, like this. So a 4 by 4. You do a 4 by 4. So this right here shows 1/3. This shows another third. This shows one more third. And up to that point, if I just do 3/3, that represents what? What amount of the brownie does this represent? 3/3. It represents a whole. But you need to include an extra third. So now you have more than a whole. In total, you would have let's do the measurements. If each third represents 16 squares, you would have 16 extra squares after 48, which would be 64. So this right here, 4/3, is a total combination or a total amount of 64 little squares. Okay. All right. Now I promise you guys that the work we do today is not just going to be fractions. This is all we're doing right now is just setting you up for fractional exponents, which we will see in the next section. Now there is one final set of questions that I would like for you guys to do. It's this challenge question. Let's just try out 5 minutes, see what you guys can do, and then we'll move on to some guided notes with some actual exponents. All right, so go ahead and try this out. All right. So let's take a look at this question now. It says stickers are sold in sheets. The diagram below shows 5/4 of one sticker sheet. Now this was a trick question. I'll tell you why. So the first thing is how many total smiley faces make up this diagram that we have below? How many smiley faces do we have in total? We have 40. These are 40 smiley faces. Now this doesn't mean you're going to split 40 into 4 parts because 40 is more than a whole sheet. So this is going to be a little tricky. Instead, you want to figure out how many smiley faces should you have in each group, so that if you were to have 5 groups, that would represent 40. So I heard it somewhere. Kilani? Good. So we have to split it into 8s. So let's say I split it into 8. So that's 1 group, 2 group, 3 group, 4 groups, and we have 5 left over. So that means that each group is made up of 8 smiley faces, so that if we were to have 5 groups, we would then have a total of 40. So in the diagram above, circle and label what 1/4 of a sticker would look like. It would be 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. You can do it like that. I'm just doing it like that because I don't have a lot of space, but you can do it whichever way you feel like doing it. Okay, if you have one sticker, what fraction of one whole sheet do you have? So one sticker represents what? Well, first of all, let's talk about what exactly is one whole sheet. 40 stickers is 1/4 more than a whole sheet. If we know that each group needs to have 8, then I would have the following. I would have 8 plus 8 plus 8 plus 8, giving me a total of how many stickers? So ignore these for now. Let's just do these sets of these groups right here. How many total stickers would I have? 32. So one whole sheet is made up of 32 stickers, which means if you just take one sticker, the sticker is actually 1 out of 32. It's 1/32. That's what it is. All right. Now, let's say I wanted to do the following. Now, let's say I wanted to figure out what 3/8 of a sticker sheet looks like. Well, what does 1/8 look like to begin with? Notice how I already have it split into fourths up here. How do I go from 1/4 to 1/8? What do I need to do here? I would need to split it again in half. So I could split this again in half, giving me groups of 4 now, meaning groups of 4 stickers. Each group of 4 sticker makes a total of 8 groups that add up to 32. So we would have this right here is one group, right? This is 1/8. This right here, another group of 4 is another 8. And then if I wanted to do 3/8, I would need to make a third group, giving me a total of, what is that? 4, 8, 12. 12 stickers. Does that make sense so far? Okay, very good. Excuse me. All right. How many stickers are there in 7/2 of a sheet? Once again, we got to go back to our sheet, look at it. How can we split this in half? Well, this is in fourths, so instead of having so many groups, I would just need 2 groups. And by the way, I'm going to cross these out because these are extra. So we're just looking at these 2 groups here. That's one group, that's another group, right? That's split into 2. How many smiley faces or how many stickers are there in each group now? 16. So this is 16, and this is another 16. So that means that 1, 2, 3, 4, 5, 6, 7. You need to do a 4x4. So 16 represents 1/2. 16 or 1/2. How many groups would I need then? How many groups of 16 would I need to show 7/2? I would need 7 of these. So I would need to do. I'm not gonna do 16 smiley faces. It's gonna take too long. But let's call this a half. So that's 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, and then it's an extra one, 7 halves. This is a 1/2, 2 halves, like that. Right, this represents a total of 7/2, which is equal to 16 times 7. 16 times 7 is, let's figure this out. 8 times 7 is 56. Double that is 112. So this is 112. I believe. Let me double check. I don't want to give you guys the wrong answer, especially not on tape. That's correct. It is 112. So 112 stickers total. Okay. All right. So we're going to take a break now. When we come back from a break, we are going to explore fractional exponents. So we're going to pause right here. Okay, so now we're looking at fractions and exponents or fractional exponents. We're going to do a structure of I show you one or we show one, we do one together and then you do one on your own. So let's begin by looking at question 8a. 4 times 7. Now something like 4 times 7 is going to require us to write 4 groups of 7. That's what we want to do. Multiplication is just repeated addition. So I have 4 groups of 7. Pretty straightforward. That's equal to 28. Using that logic of repeated whatever operation it is, when it comes to exponents, we're doing repeated multiplication. So that 8 to the third becomes 8 times 8 times 8, which is equal to, that's a big number, 8 and 8, 64. 64 and 8. Let me just look at my numbers here. That's faster. 512. All right? 512. All right, you are trying 5a and 5b on your own now. Go ahead and expand those out. If you're multiplying, you're doing groups of addition. And then if you're doing exponents, it's groups, but this time you're multiplying. Okay? Take 1 minute. All right, 5a. It's 5 groups of 11. So you're adding 11 5 times. What is that supposed to equal? 55. Very good. 5b is 3 times itself 4 times, which is 81. Okay. All right. Any questions so far? All right. This we haven't done fractional exponents yet. We're getting there. I promise. Okay. So now let me show you fractions. If I want 1/2 of 100, then I'm thinking of 2 groups that are, have like, how do I say this? 100 split evenly into 2. So I would have 2 groups. How much should each group have so that I get 100? 50. Right? So once again, I'm splitting this into halves. It's 1/2, 1/2. This is 1 whole. So the answer is 50. I'm avoiding using like just straight multiplication because I want to show you like visually. That's why. Okay, ready for this? 100 raised to the 1/2. I'll tell you right now, 100 raised to the 1/2 is not 50. 100 raised to the 1/2 is telling you the following. The same way you want 2 groups that add to 100, now you want 2 groups that multiply to 100. So think of 2 numbers, or the same number twice. What number times itself gets you 100? 10. And we want one of those. Right? Our solution is 10. Okay. Let's see how well you guys understand this. Go ahead and give it a try for 7a and 7b. Okay, 7a. What did we get for 7a? We want to split 45 into thirds, so 3 even groups. That's 1 plus, or whatever this is, right? So 1/3 plus 1/3 plus 1/3 equals 45. How much should each group have? 15. Now, how many thirds do I want? I only want one of them. So my answer is only one of these. So 1/3 of 45 is equal to 15. You guys okay with that? Does that make sense? How splitting it into like even groups gives us the answer? Are we all good with that? Okay. With that same idea, then you should have split 81 into how many groups? How many groups are you supposed to split 81 into? It's not one group. Look at the fraction. It's 1/4. So you want 4 even groups. So that's one group times another group times another group times another group equal to 81. Think about the number that multiplied by itself gives you 81. 3, very good. So each group needs to have 3 so that when I multiply 3 by itself 4 times, I get 81. How many of these do you want, though? How many groups do you want? You only want one group. So 81 to the 1/4 power is equal to 3. That's your solution. Okay? Okay. So it's pretty easy when you have everything in terms of a 1 as your numerator. It gets more challenging when you have a bigger number than a 1. So let me show you how to do 8a. Starting with repeated addition in this case, right? We're doing the groups. So I want 12 split evenly into 6 groups. Or sorry, 12, not 2. Did I say 2? I meant 12. So I want this split evenly into 6 groups. 1, 2, 3, 4, 5, 6. This is equal to 12. How much should each group have? Yes, 2. So that's 2, 2, 2, 2, 2, and 2. So I get 12 altogether. How many of these groups do I want? I want 5. So I want all of these. So 5/6 of 12 is equal to 10. Right? If I add 2 5 times, I get 10. Okay? And I'll highlight them anyway just to add to the visuals. Oh, not that one. All right. So basically, you're adding everything that is highlighted together, you get 10. So now when you do fractional exponents, it's sort of the same thing. 8 to the 2/3, I want 3 groups. So 1, 2, 3 groups that multiply to 8. So what number times itself 3 times gets you 8? That's 2. How many of these groups do I want? I want 2 of them. 2 times 2 is 4. So my solution is 4. Okay. So 8 raised to the 2/3 power is equal to 4. All right. Try the next one on your own. See how well you understand this. Try out 9a and 9b. I'll leave this up for you guys to try it out. Okay, so looking at 9a, how many groups do I want? I want 48 split into how many groups? 4 groups. So that's 1, 2, 3, 4 groups equal to 48. Of course, I'm adding all these together. How many, or what should I have in each group? I should have 12 in each group. And how many of these groups do I want? I want 3 of them. So 3/4 of 48 is 36. Are you guys okay with that? Perfect. Now let's do 16. I need 16 split into 4 groups. Now the operation is different. I'm not adding these, I'm multiplying them together. Which means I need 2 inside of each group. And how many groups do I want? 3. 2 times 2 times 2 is 8. So my solution is 8. Are you guys understanding that part? So the bottom number of the fraction, the denominator, tells you how many groups you need to split evenly into this. And then the top number tells you once you have the number, how many of those you want, and then you multiply those together. Okay, so that's how it works. So let me show you 10a. 10a. 7/4 of 20. So I want. So now we have an improper fraction. So I have more than I need now. So, or I need more than I have. So I need this split into fourths to get 20. How much should I have in each group if I have 20 split into 4 evenly? 5. And how many groups do I need? 7. So I need more than 4. So I'm actually going to have more than that. So I have, I'll do circles now, because that's probably easier. 1, 2, 3, 4, 5, 6, 7. And each one of these is 5. So you get 35 total. That's your solution. Yep. Are we okay with that? Okay. So now look at this one. Also an improper fraction. 49 raised to the 3/2 power. So the denominator, once again, the 2 tells me I need 2 groups, basically 2 numbers that multiply to 49. Those 2 numbers would be what? Same number, by the way. 7 and 7. But I need 3 of these. 1, 2, 3. So 7 times 7 times 7. Now, unless you had a calculator, you wouldn't know what this is. So I'll just give this to you. This is equal to 343. 7 and 7 make 49. 49 and 7 make 343. But the concept is that. All right, so go ahead and try out 11a and 11b now. All right, so you should be moving on to 12a and 12b now. Like I said, I'll put the solutions up for 11 and 12, or 11a and 11b. So 3 groups of what to get 21? 3 groups of 7. We want a total of 4 of these. 7, 7, 7, and 7 make a total of 28. Oops. And then 11, 3 groups multiplied together to equal 8 would need to be made up of 2. And I want 5 of these, so 2 times 2 times 2 times 2, which is equal to 32. Okay, check your solutions for 11a and 11b. The first answer should be 28. The second answer should be 32. Take 1 more minute to finish up 12a and 12b if you haven't already finished. All right, here are your final solutions then. 24 split into 4 groups would need to have 6 in each group. If I have 5 of these, that's 6 plus itself 5 times, which is equal to 30. 12b. So groups, 3 groups that multiply to 125 would need to be made up of 5 in each group. 5 times 5 times 5. So a total of 4 times is 625. Final solution is 625. All right. Are there any questions? Do you guys have any questions on how to find the fractional exponent solution? I hope that the fraction worked. The idea of splitting into groups allows you to see this clearly. What I would like for you guys to do now is we're going to finish class. We have about 20 minutes, 25 minutes. You're going to take the remainder of class to finish your team challenge problems A through H. All right. Please work on this together as a team. If you have any questions, call me over. Thank you.